All right, ladies and gentlemen, today's class was spent working on some practice problems, and those are in your daily agenda here. So we began by taking a look at this first problem, which was to find the density of 24.3 grams of gas at a pressure of 97.6 kPa and 18.7 degrees Celsius. So if you want to do this, pause the video now. If not, I'm going to go on to the answer. So density is found by taking mass divided by volume. I was given the mass of 24.3 grams. I was not given a volume. You could do this problem one of two ways. You could solve it with PV equals nRT, putting in your pressure, 1 mole, the R value for kPa, and the temperature in Kelvin, getting 24.8 liters, plugging it into the bottom of this formula, getting 0.980 grams per liters for the density. You could have also done it using combined gas laws here, putting the conditions on one side, standard conditions on the other. You would have still gotten 24.8 liters. After that, ladies and gentlemen, we went to this question. What is the density of the following gases not at STP, but under the same conditions? Propane gas, and I give you a formula because I don't expect you to know how to write the formula based on the name propane gas. Nitrogen dioxide, should be able to write a formula for. Sulfur hexafluoride, should be able to write a formula for. Argon gas and bromine gas. The density of argon gas under these conditions is 4.21 gram per liter. Pause the video if you don't want to see the answers. First thing I did was I took and I found the formula masses of all of the gases, assuming that we had 1 mole of each. Formula that I'm going to use is the mass of A over the mass of B is proportional to the density of A over the density of B, and I'm given the density of argon gas. So argon gas mass and density are going to go into the bottom of this formula. I'm then going to substitute these masses in for the top here so that I can calculate the densities. Here are the answers that you can see over here. For propane, it was 4.65 grams per liter. For nitrogen dioxide, it was 4.85 grams per liter. For sulfur hexafluoride, it was 15.4 grams per liter. And for bromine, it was 79.8 grams per liter. Same formula used 4 times to find the density of each.
Hello, Mr. Brand.
Hello, Sophia. Finally, the last question I gave them was this. What is the velocity of the following gases not at STP but under the same conditions? Ethane, C2H6, dinitrogen tetroxide, phosphorus triiodide, xenon gas, and hydrogen gas. The velocity of ethane gas under these conditions is 3.86. Sophia, what did you need? Oh, okay. I'm just making some notes for my kids. Okay. Pause the video if you want to work the problems before I show you the answers. Again, I begin by finding all the formula masses, but this time the formula that I'm going to use is the square root of mass B over the square root of mass A is proportional to the velocity of gas A over the velocity of B. Notice A and B are kitty corner from each now, top of one, bottom of the other. Notice also that these are the square roots, not just the masses. So I calculate my masses just like I did last time. I have one known velocity. I can plug 3 out of the 4 things into this formula and solve for the 4th. The velocity of N2O4, 2.21 meters per second. The velocity of phosphorus triiodide, 1.04 meter per second. The velocity of xenon, 1.85 meter per second. And the velocity of hydrogen gas, the lightest, 14.9 meters per second. That was what we did that day, ladies and gentlemen. There was one more that I did give them that we're going to finish working on tomorrow, but that was this one. What pressure of helium gas, what would be the pressure of helium gas with a density of 1.15 grams per liter, be at a temperature of 33.6 degrees Celsius? Not going to show you the answer because tomorrow in class we're going to go over it. That's the notes from today, ladies and gentlemen. Have a great day. We will talk to you later.